Okay, so right now I'm going to go over the 2013 free response solutions and show you how to use the rubric to grade your problems here. So for question one, part A, I wanted to know what's the probability that what proportion of the crows in the sample had lead levels that were unhealthy. So just looking at the stem plot here, unhealthy was greater than 6.0, so I have 4 values out of the sample size of 23. So 4 out of 23, that's a little bit over 17%. Taking a look at the solution guide or the scoring guideline, I'm looking at that. That's going to be an E, P, or I, and it's essentially correct if you have the correct numerical answer as a decimal or a fraction with work shown. I have that here, so that's going to represent an E. Okay, part B, going through that, I want to construct a 95% confidence interval. So it's a one sample T interval. There's 4 conditions that I need to check. Random, it stated that it was a random sample. I'm going to assume that one crow's lead levels are independent of the next. 23 is less than 10% of all crows, specifically in the region. And for the nearly normal condition, I have the graphical display to look off of. Again, the stem plot. I'm going to turn this horizontally, so I'm going from least to greatest. This is approximately, it's unimodal and roughly symmetric, so the central limit theorem is going to apply. So my closing statement, the conditions are met. I'm going to use a T model with degrees of freedom 22 for a one sample T interval. Mechanics, I have my sample mean plus or minus my critical value, which I got using my formula sheet, 22 degrees of freedom, 95% confidence, and then my sample standard deviation over the square root of my sample size. Using T interval in the calculator, I got that interval, and for my conclusion, we're 95% confident that the true mean lead level of crows in the region is between those two values, parts per million. So, scoring. Section 2, looking at the guidelines here, it's essentially correct if I identify a one sample T interval for a population mean either by name or formula. I have the name here, one sample T interval. And any reasonable comment about the normality displayed is acceptable. I have that. Okay, if I look at their model solution here, I have the correct procedure and saying that it's randomly selected and that it's normally distributed. I've done both of those things. I've met both of those conditions. So that second part, part B, is going to be essentially correct. For the mechanics, grading section 3 here, it's essentially correct if it gives the correct confidence interval, which I did. Supporting work is not required, but if included, it must be correct. Partially correct, you can kind of see what's going on there, but the key thing is I have the correct confidence interval, and if you look at the answer key for what they've shown, there's their confidence interval. You didn't need to show plus or minus the margin of error, but there's my confidence interval. So for that part, my mechanics, that's going to be essentially correct. And the last part of the grading is for your interpretation. So there's 4 things that they're looking for. You need to talk about estimating the mean. It's an inference about a population, so you can't be talking about the sample here that you mentioned 95% confidence. And context. Specifically, we have the lead level or the parts per million and crows. So in my conclusion, we are 95% confident, there's the confidence, that the true mean, there's the estimating a mean. Inference about a population, that's the crows in the region, is between this and this parts per million. There's my context. This would essentially be correct as well. So for this one, you have 4 parts. They're all graded, I believe, E, P, or I. Yep. E is going to be worth 1 point. P is going to be worth a half a point. Sum these up. I have 4 E's. In this case, this would be a score of a 4. Okay, next we're going to take a look at question 2. Question 2 gets into different types of sampling and bias. So for part A, I've yet to check the rubric, so there was a couple of these that were a little trickier. Let me fix this a little bit. Okay, so I said the first 500 students who enter the game could love football and they don't care about the appearance of the building and grounds at all. so they're more likely to say the appearance is okay. As a result, our estimate is too high. We've overestimated. So taking a look at scoring this. Essentially correct. There's three components. Provides a reasonable explanation of why the sample may not be representative of the population. Mentions a link between the non-representative nature of the convenience sample and the variable of interest. So the opinion about the appearance of the grounds. And three, I need some kind of plausible direction for the bias. Okay? So it says identifying the direction of the bias. Too high, too low, they're more or less likely to be satisfied with the appearance of the building. So in their model solution, they said they're differing than the rest of the population with regard to too many variables. They may have more school pride, so that may be related to their opinion. So they have a very positive opinion on things. So it's overestimating. Here's the key word, overestimating your population proportion. So kind of as I'm grading this and looking at my own, a reasonable explanation of why the sample may not be representative. I think I talk about that here when I'm mentioning that they may not even care about the buildings and grounds because they are so interested in the football game. For part two, I need a link as to something with the buildings and grounds, so I'm talking about it right here. And then number three, I'm talking about over or underestimating and what that's going to look like. So here, I'm overestimating. My estimate is too high. That's the one part that students miss a lot, is when it's a biased sample, is it over or underestimating that? So in this case, I believe I've hit all three components. That would represent an E. If you hit two of the three components, that would be a P, and one or none would be an I. And you could argue maybe this is a P here if I didn't mention why the sample may not be representative of the population. Okay, for part B, we get into talking about doing a simple random sample. So taking a look at what I have here, let's take a look at what the scoring says. Okay, so there's three components that you need to meet to earn essentially correct. Assigns numbers to the student names, uses a computer random number generator to generate 500 distinct or unique, no repeats, numbers between 1 and 70,000, and select students whose names correspond to those. Partially correct if 2 out of 3, and incorrect otherwise. Okay, so I said number the names alphabetically from 0 to 69,999. So that's component 1, assigns numbers to the names. Use a computer random generator, and the first 500 numbers in this range, ignoring repeats, will represent a simple random sample. So I've done component 2. Component 3 I have not done. I have not followed up and said I need to select those students whose names correspond to those 500 numbers. So I've done 2 out of the 3 components. This would represent a P, partially correct. Okay, part C. Scoring part C is going to look like this. It's essentially correct if the response correctly notes the circumstance described requires more variability in opinions about appearance between the campuses than between the genders. So this is a tricky question. It asked you there's a couple of key things I thought were important here. Stratification by campus provide a more precise estimate than stratification by gender. Remember, you stratify by splitting the population into homogeneous groups that you believe differ in their opinion on whatever you're trying to sample. So if I believe that people at different campuses are going to have a different opinion on the buildings and grounds and not their gender, that would provide a more precise estimate. So in my response here, I said that if the students at different campuses have a largely different opinion on the appearance of the grounds, where the two genders have a similar viewpoint, then stratification by campus will take into account the campus-to-campus variation, when it would not be accounted for if stratification by gender was used. So what I'm saying is, if we just randomly sampled some men and some women, but they were at different campuses, that difference in opinion by campus would never show up. And that's what it's trying to explain in the scoring rubric. It can be a little awkward, especially with the partially correct. So I believe that I've talked about that. there's more variability campus to campus than between gender. So I would score that essentially correct. So I have essentially correct for part A, partially correct for B, and essentially correct for C. Looking at the guidelines, if you have two parts essentially correct and one part partially correct, this would correspond to a 3. Remember, your goal for question 1 through 5 is a 2 or higher. Okay, moving on to question number 3. Okay, so in part A, pretty straightforward. We're looking to calculate a z-score and just use norm CDF to get that probability. There's 3 components that the scoring guideline is looking for, those being indicates the use of normal distribution, correctly identifying the parameters, use the correct boundary, and then get a probability consistent with those 2. So you'll notice here, I've identified the normal model and the parameters. I've gotten my z-score and that boundary. Those are all 3 components. That would represent an E. Part B, this starts to get a little more complex. Okay, they want to know what the mean of a single randomly selected egg is. Well, there's a lot of things we have going on. We have a full carton that's normally distributed, the weight of the empty carton that's normally distributed. When I take the empty carton plus 12 eggs whose weights are independent, it told me that in the problem, that's going to equal the weight of a full carton. So what I did is I took the mean weight of the empty carton, 20, plus the expected value of the weight of each of the 12 eggs is going to equal this 840. And essentially what I'm going to do, since these expected values are all going to be equal, I'm going to do 840 minus the 20, the weight of the empty carton, and divide it by 12 to get the weight of one egg. And that's where the 68.33 grams comes from. Taking a look at the solution guideline here. All right, they've identified a couple of random variables. W is the weight of the whole thing. Walk through this, essentially we're getting to the same point here. Notation, it doesn't need to be perfect to earn essentially correct, so the 68.33 grams. So that's going to earn me an essentially correct. Part 2, this question was, in my opinion, the hardest on the whole free response. It's kind of the same thing, and this is one where I felt like I wanted to take a look at the answer key because I didn't feel very confident in my answer, and as I'm looking at it now, I'm wrong. Essentially what you need to do if you take a look at the solutions, because the variables are independent, their variances are going to add. So I have the variance of the whole weight is going to equal the variance of the empty carton plus the variance of each individual egg. Okay, so the variance of each individual egg is going to be the same, so that's where that 12 comes from. We were told the standard deviation of the full carton and the empty carton, so we're calculating those 2 values, and then we're solving this equation. So let me make some corrections to what I have so you can kind of see what I did. I took the standard deviation of the full carton minus the empty carton and ended up dividing that by 12, which you can see is incorrect. So what I needed to do was the standard deviation of the full carton, find the variance, so the 7.9 squared. I don't need to write this out. Let me take a look at grading myself here. Okay, there is a few components that they're looking for, that you subtract the variances. I did that. Correctly uses the 12 in the calculations. I did not do that. And report the correct standard deviation consistent with components 1 and 2. I didn't really do that either. So I'm thinking, well, I kind of did 2 things correctly. I subtracted the variances and I divided by the 12, but my process for doing that was incorrect. So in my opinion, I think I hit these 2 criteria. I subtracted the variances and I correctly used the 12. So that would be a P. Possibly an I. And as I'm looking at these, oh, here we go. Examples of incorrect calculations. This is exactly what I got, that 0.673. So that's going to be an I. So as I look at the scoring guideline, I have 2 parts essentially correct and 1 part incorrect. That's going to represent a 2. So on this question, I scored a 2. Okay, let's take a look at question 4 in the next video, 4 through 6.